Okay, so welcome back. Having looked at arithmetic series and sequences in the previous lesson, the next lesson is going to be about geometric sequences. Arithmetic sequence is one where we add the same amount every time, where the difference is always the same. In a geometric sequence, we're going to multiply by the same amount every time. So I could start off with 5 and then multiply that by 3 and I get 15. Multiply it by 3, 45. Multiply it by 3, 135. Multiply it by 3, and so on, like that. So it doesn't make sense to talk about the differences in this example, because the differences, here the difference is 10, here it's 30, here it's 90, here it's 270. The difference isn't always the same. What's always the same is the ratio. What you may have just noticed, however, is that the differences up here also form a geometric sequence. It's being multiplied by 3, multiplied by 3, multiplied by 3. And that's an interesting little property of geometric sequences, is that their differences also form a geometric sequence with the same ratio. So here the ratio is 3, it's the same as there. So that's one way you can recognize them. So here we've got the ratio, which I'm going to call R. And we're still going to have the first term, we're calling that U1. And we want to be able to write down an nth term, just like we've done for the arithmetic series. So the first term is U1, and the second term, how do we work out the second term, U2? Well, it's obviously just the first term times by the ratio. Third term is you take the second term, exactly the same, and times by the ratio again. You can probably see what's going to happen. The fourth term is we take the third term, and we times it by the ratio again. Now if we do a little bit of simplifying, that's U1R, that's U1R squared, and that's U1R cubed. And you'll see if let's put the index on the 1 as well. What if we wrote the similar thing for U1? U1 is U1 times R to the 0. So in the nth term, in the fourth term, it's R cubed. In the third term, R squared. In the second term, R to the 1. And the first term, R to the 0. So in the nth term, it's U1 times R to the n minus 1. And so if I asked you, as I'm about to, if I gave you a sequence and asked you to find the nth term, you should be able to do that. Let's say you've got a geometric sequence where the first term is 8 and the next term is 4. You should be able to tell me what the 10th term is. What's U10? We know what U1 is. And we know what R is. We should be able to work out what R is, because what's it been multiplied by here? It's been multiplied by a half. So the ratio each time is a half. And if I want to find U10, I'll just plug it into the formula. that n not look like an r. u1 times r to the 9, which is 8 multiplied by a half to the power of a 9. You should all know that half to the power of 9 is 1 over 512, and 8 times 1 over 512 is the same as 1 over 64. So here's a couple of questions I'd like you to do before you come to the next lesson. Firstly, if I have a geometric sequence where the first term is 10 and the ratio is 2, then can you tell me what the 7th term is? That's dead easy. That's just using the formula. A little bit harder. That's something I'd like you to think about. If I tell you that the third term is 343, and the fifth term, let's say, the fifth term is 49, can you tell me, and it's a geometric sequence, I'm telling you that, so that's a fact you happen to know. Can you tell me what u1 is, what the ratio is, exactly, not as a decimal, because it's not a whole number in this case, and can you tell me what, I don't know, u8 is? So those three things. That's two questions. One dead easy, should cause you no problems. The other one should require you to think just a little bit. And I'd like you to bring the solutions to the lesson ready for us to get cracking on the exercise.